Today we're talking about one-sided limits, and this is actually a concept that we've been doing. It's just we're going to add a little bit of a new notation. But what we're going to start with is a weird function that looks like an absolute value over itself. This is going to be a special kind of limit, and the easiest thing I can tell you to do is to remember what the graph of each of these looks like, and then remember your function transformations. So if I look right here, this is the absolute value of x over x. And this is actually what this picture looks like. So if you were to type it in your calculator or get a table of values, this is what the picture would look like. And it makes sense. The absolute value, when you plug something into an absolute value thing, it just counts the distance away from zero you are. So you're taking, if it was a negative number, it'll make that into a positive number, and then you're going to divide it by itself. So your answers are all going to be 1 or -1. So if I'm looking at this, and I'm looking at the limit as x goes to 0 of this particular function, again, this is this graph, as I'm coming in from the right side, we know that limit is going to be +1, and as I'm coming in from the left side, my answer is going to be -1. So for this particular case, we can't find that limit. That limit does not exist. Okay, now if you look at the second example, it's going to look very similar to that other graph. We just have to remember my function transformations. So inside my function, I've subtracted 5 from x, which means that I'm going to move my function horizontally. And remember, your x is a liar, so it goes the opposite direction. So it's going to go right 5. So if I was to sketch this graph out for myself, it's going to look terrible. Okay, I would go 1, 2, 3, 4, 5, and that's where that little split is going to happen. It's still going to be at 1 and -1, because all I've done is move it right. I haven't moved it to the left. Or sorry, I haven't moved my vertical or horizontal shift. So that's what it's going to look like. So if I look here, again, I'm going to 5 on this. X is 5. So 1, 2, 3, 4, 5. As I'm coming in from that right side, my limit is again at 1. But as I'm going to the left side, or from the left side, it's at -1. So this limit does not exist either. If, though, they give you a number that's like 4, something that's not at that break point where it jumps in the graph, I can go ahead and I can just look at that point. And so if I went to 1, 2, 3, 4 right here, I would see that that graph from either side is going to be approaching the same number, and that's -1. So when you're looking at these, just be careful what number it is. Is it at the break, or is it going to be okay on both sides? Okay, so let's talk about a little bit of our notation. Here's a lovely piecewise function. So if I remember, when I'm looking at this graph and I'm looking for a limit, I say as the limit is x is going to 0, so as I'm coming in from the right side, I see right side that it's going to 4. My function itself is going to 4. And as I'm coming in from that left side, it's also going to 4. So that limit does exist. It's at 4. Okay, so we've been doing that, no big deal. So let's look at the limit as x goes to -1. So if I'm looking at -1 and I'm coming in from that right side, you're going to see that it's going up at 4. So my y is still trying to get to 4. It's open circle, but it's trying to get to 4. And as I'm coming in from that left side at -1, we're just going to call this 1 down here. I'm going to say that my graph is going to 1. So since they both are not equal to the same thing, this limit does not exist. But if you look at this right here, this is the same idea. It says the limit as x is going to -1. This little plus sign just means from the right side. So the plus sign means from the right, and that means that the negative or the minus means from the left. So both of these are just notations for me talking about left side, right side. So now I don't have to say RS, LS anymore. Okay, so if I look here, and again, we already did this part. As I'm coming in from the right side, my graph is getting really close to 4. But as I'm going in from the left side, that's going to get me +1 for my y value. And again, since these two don't equal each other, my entire limit does not exist. So if I look at this, again, this is the same stuff we've been doing. We just added a little symbol next to my number. So if I go to -4, and I'm coming in from the left side, because it says a negative on it, -4 is right here. My graph is getting closer and closer to 1. If I'm going, though, on my graph from -4 to the right side, my graph is getting closer and closer. We're just going to say that's -4 down there. Pretend that dot's right there. And so if I look here, again, these two numbers don't equal each other from the left side and the right side. So my limit does not exist at that point. There's a break in the graph. Okay, one more of these. If I am looking at the limit going to 1, again, I'm going to look, the plus sign means right side. So as I'm coming in there, my graph is getting closer and closer to 4, right? And then as I'm coming in from the left side, man, there's a lot of arrows up here. Again, I'm getting closer and closer to 4. So since these two numbers equal each other, that means that that limit does exist and it is equal to that number. Okay, now you have to be careful here because I do have this dot that's stuck here down here. So this graph isn't continuous. There's a discontinuity here. So if I asked me to find the function value at 1, remember I'd go to that solid circle and I would say that function value is 2. So I still have to pick up my pencil in order to draw this graph. There is a discontinuity, but the limit does exist here. Okay, same deal at -1. Be careful on that one. If I was trying to find the actual function value at -1, the limit doesn't exist, but I could find a value for that function. It has a closed circle, and we called that closed circle 1. Okay, so be careful when you're looking at one of these crazy graphs. The last thing I want to look at is one of these where they don't give you the picture. Again, you're more than welcome to draw a picture for this piecewise graph, but I can just use what I know in order to find these left and right side limits. So the biggest thing that helps me on these is to remember that a less than is the left side. And remember, now that's a negative if they put a little negative in the superscript. Okay, where a positive is a right side, and that's going to be your greater than. So if I am looking at the limit as x goes to -1, and that has a little plus up there if you can't see it, that's going to be from the right side. So right side is greater than, so I'm looking where is x greater than. And I see it's in that second equation, so I'm going to go ahead and plug in -1 into that second equation. So I'd have -1 plus 6, so negative is a positive, and that would give me 7 for that particular limit. Okay, and do the same thing. I'm going to go to the right side though, or sorry, to the left side. We already did the right side. And so that's less than. So I'm looking, where is x less than -1? It's up here. There is nothing to plug in. It's 7. That would be my answer for the left side limit. And so if I look here and I want the entire limit as x goes to -1, since both of these things equal each other, that means that my limit does exist and it's at that number. Okay, same deal if you're looking at 3. So this again, if it has a negative, that means I'm coming from the left side. And I'm looking for a less than, and I'm looking for 3 here. Okay, so that's this guy. So I'm going to go ahead and plug that in. That'll get me -3. Remember, there's a negative sign in front, plus 6, which gives me 3. Okay, then I'm going to do the same thing from the right side, because that's what that little plus sign means. And now I'm looking for greater than. So I'm going to have 2 times x, which is 3, and that gets me 6. So if I look here, my left side doesn't equal my right side, which means that my whole limit does not exist. However, there is a function value at 3. Remember, you're more than welcome to plug it in because there's an equal sign right here. And we just found that out. We said that when x was 3, in this equation, I got 3 for y as well. So again, you can have a function value, but you don't have to have an existing limit. So biggest thing today, remember, plus sign means I'm coming in from the right side. Negative or a little minus sign means I'm coming in from the left side. That's the only new thing. And break.